What if I told you that for the first time in human history, we are no longer guessing what other worlds look like, we are actually seeing them? A real photograph of a planet floating 111 light years from your window has just been captured, and the story behind that single image is stranger and more emotional than anything Hollywood could ever script. Before we go any deeper, do me one small favor. If this kind of story makes your mind race a little, tap that like button, hit subscribe, so you never miss a discovery like this again, and share this video with the one friend who always looks up at the night sky and wonders what is really out there. That tiny action helps me bring these stories to more curious minds like yours, and it costs you nothing but a second of your time. Now let us step into what actually happened, because this is not a normal space update, this is a turning point. For most of human history, other planets around other stars were pure imagination. We could dream about them, paint them, write novels about them, but we could not see them. Even after modern astronomy proved they existed, we were still stuck detecting them through shadows and wobbles, never through a proper photograph. Think about that for a moment. We have known for decades that thousands of planets exist beyond our solar system, yet almost none of them have ever appeared in an actual image. The number of confirmed exoplanets right now sits at more than 5,900. 5,900 worlds. Some are lava-covered. Some are frozen, some circle two suns at once like a scene from a movie, and some may even have oceans hidden beneath thick clouds. And yet, out of that entire catalog, only a tiny handful have ever been directly photographed. The rest were found through indirect tricks, methods so subtle that they feel closer to detective work than photography. Picture this. Imagine you are standing in a completely dark room, and you want to prove that a person is walking across the other side. You cannot see them, but you can see a single lamp behind them. The moment they pass in front of that lamp, the light dims for a split second. That flicker is your proof. That is basically how most exoplanets were discovered. Astronomers stared at stars, waited patiently, and every time a star dipped slightly in brightness, they knew a planet had just crossed in front of it. That method, called the transit method, has been the backbone of exoplanet science for years. It works, it is powerful, but it has one huge limitation. You never actually see the planet. You only see its shadow. You know it exists the way you know a ghost exists in a movie, through hints, through disturbances, never through a face. That is why what the James Webb Space Telescope just did feels almost unreal. Webb did not wait for a shadow. Webb did not measure a wobble. Webb pointed its golden eye at a distant star, blocked out the blinding glare of that star, and captured the planet itself, glowing quietly in the darkness. A real, direct, honest photograph. And not of some enormous monster world larger than Jupiter. This new world is small by cosmic standards, roughly the mass of Saturn, which makes it the lightest exoplanet ever directly imaged in the entire history of astronomy. The previous record holder was 10 times heavier. 10 times. That is not a small step forward. That is a leap that rewrites what our telescopes are capable of doing. The planet has been given the name TWA-7b. Its host star, TWA-7, also known as CE Antliae, sits about 111 light-years away in a constellation called Antlia, which most people have never heard of and probably could not point to in the sky. 111 light years sounds enormous, and honestly for a human being, it is unimaginable. But for the universe, this is basically the house next door. The observable cosmos stretches roughly 93 billion light years across. So on that scale, TWA-7 is practically leaning over our fence. And the star itself is fascinating in its own right. It is only about 6.5 million years old. Our sun, for comparison, is roughly 4.5 billion years old. So while our sun is a middle-aged adult, TWA-7 is essentially a cosmic newborn, still surrounded by the swirling leftover dust and rock from its own birth. For years, astronomers already suspected something was hiding inside that swirling disk of debris. When they looked at TWA-7 with ground-based telescopes, they noticed something strange. The disk was not smooth. It was carved into 3 distinct rings with clear gaps between them. And in the world of planetary science, gaps like that almost always whisper the same secret. Something is in there, something big enough to sweep the dust aside as it orbits, like a giant invisible lawnmower rolling in slow circles, clearing a path through a field of debris. The rings were the fingerprints of a hidden planet, but nobody could see the planet itself. It was there in theory, invisible in practice, and for years, that mystery just sat waiting for a telescope powerful enough to solve it. Now, why was it so hard to see? Let me paint the challenge in a way that sticks with you. Imagine trying to spot a firefly hovering right next to a stadium floodlight from miles away. The floodlight is blasting so much light in every direction that the firefly is completely swallowed. That is what looking for a planet next to its star is like. Stars are almost impossibly bright. Planets are almost impossibly dim in comparison. Trying to photograph a planet next to its star is basically trying to see a single candle sitting on the surface of the sun. This is why direct imaging of exoplanets was, for most of human history, considered borderline impossible. Not difficult, not tricky, actually impossible, with the tools we had. And this is where Webb changes the game. Inside the telescope sits an instrument called MIRI, the mid-infrared instrument, and inside MIRI is a piece of technology called a coronagraph. Sounds simple, sounds like a fancy name for a lens cover. It is not. A coronagraph is one of the most delicate pieces of optical engineering humans have ever built. It sits in front of the star and physically cancels out its light, almost like holding a coin up to the sun so you can see what is hidden in the glare around it. But this is not just a coin. The version on Webb uses something called a 4-quadrant phase mask, which splits the incoming starlight into 4 sections and cancels it out through what is basically a mathematical magic trick called destructive interference. 2 waves of light collide, in just the right way, and the star vanishes. The planet, which was hiding in that glare the whole time, quietly appears. It is optical wizardry so precise it feels closer to sorcery than science. Even then, the star is never fully erased. Some of its light always bleeds through, like sunlight leaking around a curtain. So after the raw image comes down from space, a team of scientists led by Dr. Anne-Marie Lagrange from the French National Center for Scientific Research took that data and ran it through advanced image processing algorithms. Layer by layer, they scrubbed out the leftover starlight. They subtracted, cleaned, and refined until finally, sitting in the gap between 2 rings of the debris disk, there was a faint but unmistakable glow. A tiny infrared dot, a world nobody had ever seen before. The team was cautious. Science does not celebrate too early. They asked the harder question. Could this dot be a random background galaxy that just happened to be sitting in the right place? They ran the math. The odds that this glow was a background galaxy instead of a planet came out to about 0.34%. Less than 1/3 of 1%. In science, that is as close to certainty as you get without shouting it from a mountaintop. The findings were published in the journal Nature on June 25, 2025, and the astronomy world reacted the way it does maybe once a decade. Silent for a second, then absolutely electric. Before we go deeper into what this world actually is, I want to pause and say something honestly. If you have made it this far into the video, you are already the kind of person who thinks bigger than most people around you. So do me a quiet favor. Drop a comment below telling me one word that describes how you feel about this discovery right now. Just one word. Curious, stunned, hopeful, anything. I read those comments and they helped the algorithm push this story into the feed of other curious minds. Now let us get back into it because the details of this planet are where the story starts. To feel almost too incredible to be real. TWA7b is roughly 100 times the mass of Earth. Do the conversion, and that is about 0.3 times the mass of Jupiter, which lands it squarely in the same size category as Saturn. So this is not a rocky world you could stand on. This is a gas planet, cold, young, and quiet. It orbits its star at roughly 50 times the distance that Earth orbits our sun. In our own solar system, that would put it far, past Neptune, out in the freezing outer suburbs. Its temperature has been estimated at around 320 Kelvin, which is about 47 degrees Celsius, or 117 degrees Fahrenheit. That might sound warm to you, like a hot summer day, but for a planet still glowing with the leftover heat from its own birth, that is actually chilly. It is a baby planet, still warm from being born, still radiating the memory of its formation into the cold dark around it. Here is why that matters, far beyond a single photograph. This is the first time in history that a planet has ever been directly seen inside a debris disk. For decades, astronomers have theorized that gaps in these dusty rings around young stars are carved out by planets. It was a beautiful theory, elegant, logical, supported by simulations, but nobody had ever actually caught a planet sitting inside one of those gaps in a real image. TWA7b changes that. It sits exactly where planetary formation theory predicted a planet of its size should sit. The gap fits the planet like a glove. Theory and observation just shook hands in front of the whole world, and that alone would make this discovery historic. And there might be even more. Early data hints that TWA7b may be dragging a small cloud of dust along with it, sharing its orbit like tiny cosmic companions. In our own solar system, we call this a Trojan cloud. Jupiter has huge groups of asteroids trapped in stable positions ahead of it and behind it in its orbit. If TWA7b really does have something similar, it would be the first hint of a Trojan disk ever detected outside of our own solar system. One discovery would already be enormous. 2 nested inside each other feels almost unfair to the rest of astronomy. Now, maybe part of your brain is asking a very fair question. Why should any of this matter to you, sitting wherever you are, going about your regular life, dealing with regular problems? Why care about a gas planet orbiting a young red star in a constellation nobody can pronounce? Let me tell. You. Why? And I promise this hits differently once you actually let it sink in. For thousands of years, humans have looked up at the night sky and wondered if we were alone. Every ancient civilization asked that same question in its own language, under its own stars. Galileo pointed a tiny handmade telescope at the sky in the early 1600s and saw the moons of Jupiter, and suddenly the idea that Earth was the center of everything cracked open. In the 1990s, astronomers finally proved that other stars have planets around them, and the universe felt a little less lonely. Then for years after that, we found thousands of these worlds, but only through their shadows. We were like a detective who could prove a suspect existed, but had never seen their face. We knew the worlds were there, we just could not look at them. What Webb has now done, quietly, elegantly, using engineering that most people will never fully understand, is prove that we can finally see. Not just a giant fireball the size of 4 Jupiters, but a real planet in the same size range as the ones in our own solar system. And that changes everything, because it means the next question is no longer whether direct imaging works. It is how small can we go, how faint can we push, how close to Earth-sized can we get. Dr. Lagrange has openly said that her long-term dream is to one day directly image an Earth-like world. That dream, which used to sound like poetry, now sounds like a schedule. To push that dream even further, another giant is being built as we speak. High up in the Atacama Desert in Chile, on a mountaintop scrubbed dry by centuries of wind, engineers are constructing something called the Extremely Large Telescope. Its primary mirror will be 39 meters across, making it by far the biggest optical telescope humans have ever built. It is scheduled to open its eyes around 2028. Once it does, combined with Webb floating in space, we may enter a decade where the first genuine photograph of a potentially habitable Earth-like world becomes not a fantasy, but a real target on the calendar. Now let me be honest with you about something important. TWA 7b itself is not a habitable world. Nobody will ever live there. It is cold, it is gaseous, it has no surface to walk on, no oceans, no skies you could breathe. It was not chosen because it is exciting to imagine visiting. It was chosen because it was reachable, because it proved a method, because it opened a door. TWA 7b is the practice run. TWA 7b is the proof. TWA 7b is the opening chapter of a very long book. And every future page, every future world, every future photograph will trace back to this quiet little orange dot glowing between 2 rings of dust, 111 light years away. Take a breath here for a second, because I want to remind you of something that matters. If this video is genuinely making you feel that spark of curiosity, that little jolt in your chest that says, the universe is bigger than my problems, then please do one more small thing for me. Go up to that subscribe button and tap it if you have not already. Not because I am asking, but because you deserve to have more moments like this in your feed. The world floods us with noise, and stories like this one, real stories about real discoveries, deserve to reach the people who are still willing to wonder. All right, let us step deeper into the story now, because the next layer is where it becomes almost spiritual. Think about what a photograph actually is. When you take a picture of a friend, you're catching light that bounced off their face, entered a lens, and was frozen in time. When you look at a sunrise, you are receiving light that left the sun about 8 minutes earlier. Every image, every visual memory you have ever had is nothing more than light arriving after a journey. Now, hold that idea in your head and try to feel this next sentence properly. The light in the image of TWA 7b left that planet 111 years ago. That light traveled across the darkness of interstellar space for over a century. It left before the invention of the modern computer. It left before World War II. It left when the world was still riding horses more than cars. And after a century of quiet, cold travel across the void, that ancient light finally arrived at the golden mirror of the James Webb Space Telescope was captured, cleaned, decoded, and now sits inside a data file that scientists on our planet can study. That is not just science. That is almost a form of memory. That light is a message from a place that has no idea we exist, sent without any intention, received by beings who spent decades trying to build a machine capable of catching it. If you sit with that thought for even a minute, it starts to change the way you look at the sky. Every point of light up there is a delayed message from somewhere unimaginably far. And now, for the first time, we are learning to read those messages not as flickers, but as portraits. There is another quiet truth hiding inside this discovery. Every time in history that humans built a more powerful telescope, we were humbled. When Galileo aimed his primitive lens at Jupiter and saw its moons, the belief that Earth sat at the center of everything crumbled. When Edwin Hubble stared through the 100-inch telescope on Mount Wilson in The 1920s, he proved that the fuzzy smudges people had assumed were nearby gas clouds were actually entire galaxies, each holding hundreds of billions of stars. The known universe suddenly grew by a factor no human mind could actually process. When the Hubble Space Telescope launched in 1990 and pointed at what looked like an empty black square in the sky, it revealed thousands of galaxies packed into that so-called emptiness. Each time we look harder, the universe teaches us that it is bigger and stranger than we thought. Webb is doing this again, right in front of us, in our own lifetime. It launched on Christmas Day in 2021, unfolded its mirror over 6 delicate months, cooled its instruments to temperatures colder than most people can imagine, and then released its first full-color science images in July 2022. Those images did not just impress astronomers, they broke the internet. People who had spent 40 years staring at deep space were seen wiping tears from their eyes on live streams. Star nurseries with clouds of gas glowing like watercolor paintings. Galaxy? Clusters bending light so severely that they warp the shapes of galaxies billions of light years further behind them. The deepest infrared view of the cosmos ever recorded, showing baby galaxies from a time when the universe was still figuring out how to exist. Since then, Webb has not stopped. It has helped confirm more than 100 new exoplanets through transit observations. It has sniffed the atmospheres of distant worlds and detected carbon dioxide, water vapor, methane, and sulfur compounds. It found molecules on a distant ocean world called K2-18b that some scientists suspect might be linked to biological processes, though everyone remains careful about that interpretation because non-biological explanations are still very much on the table. Every single month has brought a new headline. Every single month has slightly rewritten a textbook somewhere. But what Webb did with TWA-7b is different in a very specific way. It was not analyzing chemistry through the light of a passing planet. It was not measuring dips in starlight to guess a planet's size. It went out looking for a world. Through direct imaging, hunted for it, aimed at exactly the right target, blocked the starlight, processed the noise, and returned with an actual portrait. That is a full closed loop of discovery. Prediction, observation, confirmation, publication. Every step landed exactly where it should. That is not just a lucky snapshot. That is proof that a new method is now open for business. The difference between the two methods is enormous, and it matters for the future of everything we do out there. Transit spectroscopy, where you analyze starlight passing through a planet's atmosphere, only works if the planet passes directly between us and its star from our angle of view. From our position in the galaxy, most planets never do that. Most planets orbit at angles that never line up with us. That means for most of the exoplanets in the universe, transit science can never see them. Direct imaging has no such limitation. If a planet is bright enough and the coronagraph is powerful enough, we can photograph it no matter where it sits in its orbit. Suddenly, the pool of worlds we can study opens up in a way that changes long-term planning for every future telescope humanity will ever build. Let me stop here for a quick moment. If this is the kind of content that reminds you why science is beautiful, why curiosity is a superpower, and why the universe is worth paying attention to, then here is your challenge. Send this video right now to one specific person. Not your whole group chat, not a random contact. One person who you know needs to hear something bigger than their daily stress today. That single share is how word-of-mouth science storytelling actually works, and it changes everything for creators like me. All right, back into the story, because there is one final chapter that ties everything together in a way I think you will remember for a long time. Right now, as you sit wherever you are, breathing, blinking, reading captions, or listening to a voice, the James Webb Space Telescope is aimed at some patch of the sky, silently gathering photons from things we have never seen before. Data is being transmitted back to Earth in compressed streams and quietly processed by teams of scientists across multiple time zones. Somewhere inside that flowing river of data, there may already be the next TWA-7b, hiding in plain sight, waiting for the moment someone notices it. That thought is thrilling, but there is something even more important underneath it. Because for the first time, we are not just cataloging the universe, we are looking at it. We are moving from being scientists who list objects to being witnesses who see them. And there's a real difference between knowing something exists and looking at it in the face. When you know a person is out there, you can imagine them, but they remain a concept. When you see them, they become real in a way that words can never replicate. That is the shift that just happened for the universe. Somewhere out in the dark between the stars, a young world is quietly orbiting a young sun. And now we have looked at it. We have received its light. We have seen its face. The universe holds about 2 trillion galaxies inside just the observable region alone. Our own Milky Way holds somewhere between 100 billion and 400 billion stars. And modern estimates suggest that most of those stars carry at least one planet with them. Some with several. Some with entire families of worlds. If you tried to count every planet in the universe, your mind would break long before your calculator did. For most of history, we had no idea any of them existed. Then we detected shadows. Then we tracked flickers. And now with a telescope floating 1,000,000 miles above Earth, we are finally starting to see them. Not as data, not as points on a graph, but as light, as images, as real places. TWA 7b will end up in textbooks. Its name will feel awkward to say out loud because names in astronomy always do, but the story attached to it will outlive every single one of us. School children decades from now will read about it the way we read about the first exoplanet discoveries in the 1990s. And some of those children, some of them still unborn as you watch this, will one day operate the next generation of telescopes that finally, gently, capture the first true image of an Earth-like world orbiting another star. When they succeed, they will not thank Hollywood, they will not thank politicians. They will trace their achievement back to a small, patient team led by Dr. MIRI Lagrange, staring at a faint infrared glow in a debris disk 111 light-years away, and quietly proving that it could be done. There is something profoundly human in all of this. We are a species that started around fires, drawing pictures of animals on cave walls because we needed to make sense of a world we barely understood. We looked up at the sky and invented gods to explain the lights we could not reach. We built pyramids that aligned with stars. We sailed oceans using constellations. We chased eclipses across continents. And now, thousands of years into that same restless story, we have finally built a machine capable of doing what every ancestor of ours could only dream about. We have looked at another world and truly seen it. We are not alone in having planets. The universe is soaked in them. Every one of them has its own weather, its own geology, its own physics, its own quiet history unfolding without any awareness of us. And with this single photograph, we have taken the first real step into the era of seeing those histories rather than just guessing at them. The James Webb Space Telescope did not just take a picture. It opened a door that had been locked for the entire existence of our species. And behind that door is not one world, not two worlds, but every world waiting to be seen next. So the next time you step outside at night and look up at that dark, endless sky, remember something. Some of the tiny points of light above your head are stars with planets that we can now, for the first time, actually photograph. Not imagine, not simulate, photograph. That reality already exists. You are living in the exact moment where science stopped guessing and started seeing. And whatever comes next, whatever telescopes we build, whatever worlds we photograph, whatever atmospheres we one day decode, all of it will trace back to this quiet, extraordinary night when a young gas planet 111 light-years away sat inside a ring of dust, glowed faintly in infrared, and let us see its face for the very first time. The universe just said hello, and humanity for once was ready to look back.